Welcome back to the deep dive. When you're learning JavaScript, everyone tells you the same thing. Stay away from the global scope. It's almost treated like this toxic area, like a mistake just waiting to happen.
Right, and that reaction, while maybe well-intentioned, misses so much. The global scope isn't just something to avoid, it's fundamental. It's got a lot of nuance, and really getting how it works is key to truly understanding lexical scope overall.
Okay, so let's dig into that. We're going deep today on why the global scope is still super relevant, how it really does act as the glue holding applications together.
And crucially, where this global scope actually is, depending on the environment you're running your JavaScript in. Browsers, Node, modules, they all handle it a bit differently.
Exactly. So the mission today is to unpack how all these separate bits of code, different files, different modules, manage to cooperate and work together in one single runtime context.
And the analysis we looked at highlights three main ways this cooperation happens, three core mechanisms.
Let's start with mechanism one, the most modern way, ES modules.
Yeah, ESM. If you're using standard import and export, cooperation is pretty straightforward. Module B says, import specific function from module EA.js.
So it just pulls in exactly what it needs.
Precisely.
Yeah,
The import is the only connection point. There's no need for some kind of shared outer scope for them to see each other. It bypasses that whole issue.
makes sense. Very explicit, very contained. Okay, so what about mechanism two? That's the world of bundlers, right? Tools like Webpack or Rollup, taking lots of files.
Yes, and they often work by basically smushing all your code together and then wrapping the entire thing in one big function scope. Think of it like a giant wrapping outer scope function call.
Ah, okay. So inside that big function.
The bundler might declare, say, var module 1, code from file 1, var module 2, code from file 2. Because they're declared with var inside the same function scope, module 1 can now talk to module 2.
They're siblings in that scope.
Exactly. It's like a manufactured application-wide scope. It acts as the glue, but crucially, it does this without putting module 1 or module 2 into the real global scope. It keeps the actual global environment clean.
Right, so it's a clever workaround. But if bundlers do this, why do we still need to understand the actual messy global scope? Isn't this wrapper making it kind of obsolete for our variables?
That's a really important question. While this bundled scope handles cooperation within your application code, it doesn't cover everything. And it leads us straight into mechanism 3. Sometimes you have to rely on the true global scope.
And when does that happen? Like if you're not using a bundler, maybe? Or just loading scripts the old way?
Yeah, think about loading separate files using plain old script tags in HTML.
Mm-hmm.
Maybe you have module1.js and module2.js loaded one after the other. There's no single function wrapping them both.
So if module1.js declares something at the top level like var student name Kyle,
That variable declaration has nowhere else to go but the global scope. It becomes a global variable.
and then module2.js loaded later can just use student name.
It can, because the global scope is the only shared scope between those two independent script files. It's the default meeting place when there's no other structure provided.
Okay, so that's how our code might end up cooperating via the global scope. But it does way more than just hold our variables, right? It's also where all the built-in stuff lives.
Absolutely, it's the foundation. JavaScript itself puts tons of things there. Think about primitives like undefined, null, nan,
Natives like date or...
object, global functions like eval or parseInt,
yeah.
and even namespaces like math and JSON. They're all just sitting there in the global scope, available everywhere.
And then the environment adds its own layer of globals. In a browser, that's a huge list.
Oh yeah, everything you need to interact with the web page. Console, window, document, functions like set timeout or set interval, and all the web platform APIs like navigator, geolocation, you name it.
That makes sense for browsers. What about Node.js? Does it just dump things like require into the global scope too?
Ah, good point. Node is a bit different. It provides things that feel global, like require or process or dir name.
Mm-hmm.
But technically, they aren't properties on the actual global object. Node kind of injects them into each module scope as it's loaded. So they're available everywhere in that file, but not truly global in the same way window.setTimeout is in the browser.
Interesting distinction. Okay, so we know why global scope matters. Let's talk about where things get tricky, specifically in the browser environment. You mentioned earlier that a standalone JS file loaded via script is kind of the purest form.
Pure in the sense of following the original traditional JavaScript behavior. If you have that file with, say, var student name Kyle at the top level, and maybe function hello.
Like student name and hello go into the global scope.
Yes, they become global variables. And this is the key part. For browsers, they also automatically become properties on the global object, which is window. So you can access them as student name or as window.studentName. Same for hello and window.hello. That var and function keyword behavior is specified like that.
Okay, but that's where it gets weird with newer keywords, right? The difference between a global variable and a global property, this whole shadowing thing.
Exactly. This trips up so many people. Let's say you first do window.something equals 42. You've directly created a property on the global object.
Okay, window.something is 42.
Now, in a separate line, maybe later in your script, you declare let something in Kyle. You've used let, not var.
So now I have a global variable called something. If I console.log something, what do I get?
You get Kyle
Ah,
because the variable declaration takes precedence for direct lookups.
but what if I specifically look at the property? Console.log window.something.
It's still 42 because let and const create global variables, but they do not create a corresponding property on the window object. So the let something variable effectively hides or shadows the window.something property.
Wow. Okay, that sounds incredibly confusing and easy to break things with.
It really is,
Yeah.
especially if you're working with older code or libraries that expect global declarations to always show up on window. That's why the strong advice is, if you must create a global variable, use var so it also becomes a window property. Reserve let and const strictly for block scopes, inside functions, or blocks where they belong.
Avoid the global shadowing mess altogether.
Please do.
Even sticking with var, the browser has other weird legacy things. You mentioned DOM globals.
Oh, this is a classic piece of browser history. If you have an HTML element with an id, like on my to-do list, ul,
Yeah.
the browser automatically creates a global JavaScript variable named my to-do list that points directly to that DOM element.
Right, seriously, with the hyphens and everything, so I could just type my to-do list in my JavaScript and get the NL element?
Well, usually you'd access it via window my to-do list because of the hyphen, but yes.
Yeah.
Or if the ID was valid as a variable name, like add first, then first would just be a global variable pointing to that element as a holdover from the early days.
That seems like a terrible idea. You could accidentally overwrite it or clash with your own variable names so easily.
Absolutely terrible. Don't rely on it, ever. Explicitly use document.getElement by id or query selector. And speaking of terrible ideas, or at least confusing ones, window.name.
Ah, yes, the name property. What happens if I try to declare var name equals 42? I'm trying to make a global variable called name with the number 42.
You'd think so. But window.name is special. It's a pre-existing property on window, and it has a built-in behavior. It must hold a string value.
So my var declaration gets ignored.
Pretty much. Because the property window.name already exists, the var doesn't override it. Instead, the browser sees you trying to assign the number 42, coerces it into the string 42, and stores that in window.name.
So if I then check the value of name, I get the string 42, not the number 42.
Correct. The environment's special property rules override your variable assignment. It's a perfect little example of how the host environment can mess with plain JavaScript expectations.
Okay, so browser globals are quirky. What happens when we move outside the main browser window, like web workers?
Web workers are interesting because they run on a totally separate thread. They don't share the same global scope as the main page. And critically, they can't directly access the DOM, window, document, etc.
So they have their own global scope. What's the global object called there?
Usually it's referenced via self. So similar role to window,
Yeah.
but in the worker context.
And do var and let behave the same way there regarding self? Like, does var create a property on self, but let doesn't?
Exactly, the same behavior persists. If you declare var worker var 1 in a worker, self.worker var will be 1. But if you declare let worker let 2, self.worker let will be undefined. The distinction carries over.
Got it. What about another common environment, the developer tools console, the REPL? Is that just the browser's global scope?
Not quite, and this is a huge source of confusion. The console emulates the global scope, but it prioritizes developer experience, or DX, over strict spec adherence. Meaning, things might behave differently in the console than they would in an actual script running on the page. For instance, how the console handles redeclaring variables with let, or maybe some nuances of hoisting, might not perfectly match the spec or real-world execution.
So it's useful for quick checks, but don't trust it as the absolute authority on how JavaScript will behave in your actual program.
Precisely. Use it, but verify important behaviors in actual scripts or modules.
Okay, speaking of modules, ES modules, ESM. We said they don't rely on a shared outer scope. How does that affect top-level declarations within an ESM file compared to a classic script?
It's a fundamental shift. When a file is treated as an ES module, example script type module or in Node, any var, let, const, or function declared at the top level is not added to the true global scope.
Not global at all. Where do they live then?
They live in what's called the module scope. You can think of the entire module file as being implicitly wrapped in a function. So those top-level declarations are local to that specific module. They're module global, not truly global.
Ah, okay. So they exist, but they're contained within the module's boundary unless explicitly exported.
Exactly. The module scope itself still inherits from the global scope, so it can access math, JSON, window, etc., but its own declarations stay private by default. This encourages less reliance on the global scope.
And Node.js takes this even further, right? You said it treats every file as a module.
Pretty much, yes. Whether you're using the older CommonJS require module.exports or modern ESM import-export, Node wraps your file's code.
So even if I write var my config at the very top of a Node file,
It's not going into the actual global scope. It's contained within that specific module's wrapper function scope. It's local to the file.
so how do you create a truly global variable in Node if you ever needed to?
The only way is to explicitly attach it as a property to Node's designated global object, which is conveniently named global. So you'd have to write global.myTrulyGlobalVariable equals 123. That's the escape hatch.
Man, this variation across environments really highlights the historical problem. If the global object is window here, self there, global somewhere else, how did people reliably get a reference to it before things were standardized?
Oh, it was a mess. Developers had to write code that checked for all possibilities. Is window defined? If not, is self-defined? If not, is global
That
defined?
sounds brittle.
It was. And if none of those standard names worked, there was this infamous fallback, often called the ugly new function trick,
Which was?
literally creating a new function on the fly and having it return it's this value, like new function return this. Because inside a non-strict function called that way, this defaults to the global object. It was a hack, but it worked cross-environment.
Wow, that polyfill code must have been something else.
You can still find examples online. It would look something like var, the global indefined type
Yeah.
of global, undefined global window.
Assumption.
New function,
Wow, yay.
just layer after layer of checks.
Thank goodness for standardization.
Absolutely. ES 2020 finally gave us globalThis, one standard, unambiguous way to get the global object, regardless of the environment.
globalThis. Clean and simple.
Mostly. As the source material notes, there was actually a bit of debate about the name because it gives you the global scope object, which isn't always the same as this binding in every context. But semantics aside, globalThis is the universal solution we needed.
Okay, let's wrap this up. This has been a fascinating tour. The main thing I'm taking away is that the global scope is definitely not dead or irrelevant.
Not at all. It's there, it's active in basically every JS program you run. The key is understanding that how it behaves, like what actually ends up in the global scope and what the global object is called, changes significantly depending on whether you're in a browser, a worker, an ES module node.
And knowing those differences is crucial, especially as your code moves between these different environments.
It's absolutely essential for writing robust, portable JavaScript.
So, for everyone listening, the challenge is this. Even when you're deep in your modules, using import and keeping things local, remember, you're still interacting with the global scope constantly.
All those built-ins.
Exactly. Next time you're coding, maybe just take a moment to notice how many times you use things like object, array, JSON, set timeout, document, console, all originating from that foundational global scope.
You might be surprised just how much relies on that supposedly dangerous place. It's really running the whole show underneath.
A brilliant perspective shift. Thanks for breaking down the complexities of the global scope for us.
Happy to do it. It's a core concept worth understanding deeply.